Okay, question 26 is about graphing. It says at a concert there were 120 people lined up at the door at opening time. Okay, every minute another 40 people arrived. Construct a table of values using t to represent time or the number of minutes and n to represent the number of people. Okay, so the time we can put different numbers in. We can say it at time 0. Oh yeah, we can see in part B an extra piece of information. It says graph it. This domain means graph it between 0 and 6. So I need 0 minutes, 1 minute, 2 minutes, 3 minutes, 4 minutes, 5 and 6. That means on my graph I'm going to have it going till 6. Okay, so let's see if this works. 1, 2, 3, 4. Nope. So I'm just gonna go up in 1, 2, 3, 4, 5, 6. And this is gonna be time in minutes. And then on my y-axis I'm gonna have the number of people attending the concert. So just let's visualize how this will look like. So this is number of people attending. Number of people. Okay, so I'm not going to put any values on the y-axis just yet because I don't know what my biggest number will be. So I'm going to go back to my table of values. I know at opening time there were 120 people. Okay. What happens after that is every minute 40 people arrive. Every minute 40 people. So it's going to go from 120 to 160. 160 plus 40 is another 200. 200, add another 40, add another 40, add another 40 until we get to 360. Okay, so we are graphing it between 0 and 6. So we've got our values. We know the largest one is 360. So let's say if I got 100, 200, 300, 400, that makes my life easy. Okay, at time 0 I've got 120 people, so probably about there. At 1 I've got 160, so that's 150, 160 might be around there. 2 is 200, 3 is 240, so not quite 250. 4 is 280, should be probably around there. 5 is 320, which is about there. And 6 is 360. About there. Alright, once you got your diagram, just try and join the dots. You should probably get graph paper in the exam, but if you don't, you just want to do a line of best fits, something that goes through kind of most of the values. That's as accurate as I could get it on mine, but I've got that. So I've graphed the function, I've done the table. Now it says write an equation to express n as a function of t. So we know n is the number of people, t is time. We need an equation that is in the form y equals mx plus c because it's linear graph. Now we need to calculate the gradient m. All right, to do that it's going to be rise over run. So let's just look at the rise. So it's gone, we want to know what the rise is, so we could do the difference between there and there. So that part, the rise, is going to be we know the largest number was 360 minus 120, and then the run is going to be how much it's moved in the x-axis, which is just 6 minus 0, which is just 6. I forgot to do that, so that's going to be 240, which is what the run is. So the gradient is rise over run, which is 240 divided by 6, and that is just 40. So gradient m is 40. The y-intercept is where it crosses the y-axis, that's the y-intercept. And so in our case, we know it's 120. So I can come here and write y-intercept equals 120. Now I'll just substitute my values. So gradient is m and the y-intercept is c. So I'll rewrite my equation y equals 40x plus 120. Now the only thing is that it wants you to express n as a function of t. So we, instead of having y, because we know number of people is on the y-axis, I'll put n equals 40. Instead of x, I'll put t for time plus 120. Now I can use this function or this equation to know how many people would be there after, let's say, 20 minutes. I can plug 20 into my equation and I can know how many people would be at the concert after 20 minutes. But that's my final answer there.